Hello everyone, let's continue our discussion on MOSFETs. In the last couple of lectures we saw two important concepts. The first one was the concept of strong inversion and the second one was the concept of threshold voltage. So strong inversion or the surface inversion was nothing but under a p-type substrate there is a small n-type area or n-type channel formation. That was that is what was referred to as the strong inversion, and the potential at which strong inversion happened, that was called as threshold voltage. So in this video what we'll be doing is we'll be applying some potential between the source and the body terminal and see what happens to the threshold voltage. And by the way, there are some applications which needs this particular terminal to be connected to some potential rather than being grounded. So we have some applications. So we have to understand what is the impact of threshold voltage when we try to connect a potential between source and the body terminal. So let's do that. So let's try to consider two different scenarios over here. So the first one will be the same or the original one that we have been studying in the past videos, and the second one will be something like this. So there will be a potential that will be applied between the body and the source. So this will be calling it as positive value, VSB, as some positive potential. So why it's at positive value? So since if you look from this direction, you see there is if you see the VSB becomes positive. If you look in this direction, the VBS will become negative value. So let's try to be on the same page and call VSB as some positive value. So your source is at positive potential, your body is at negative potential. So one clear observation that we see over here, on one clear thing that is happening over here, is you have this N plus area, you have this p-type substrate, and these form a p-n junction diode. Similar case happens over here as well. You have this p-type substrate, you have this N plus area, and you have a p-n junction diode formation. But there is one important thing to notice over here is that the terminals of the p-n junction diode over here are grounded, and the terminals of the p-n junction diode over here are connected to some battery source. So let's say this is the negative terminal of the p-n junction diode, and it is connected to the positive potential, or it is connected to the positive terminal of the battery. And this is the positive terminal of the p-n junction diode, which is connected to the negative terminal of the battery. So this particular arrangement reminds us of the classic reverse bias p-n junction diode. So in case of a reverse bias p-n junction diode, you see the depletion layer width is much more than the diode which is connected to the ground, because there is an additional reverse bias that is getting applied to the p-n junction diode in this case. Whereas in this case, the p-n junction diode, the terminals of the p-n junction diode were grounded. So that's the difference that you see in this and this case. So that's the immediate effect of applying some potential between the VSB. Basically, the immediate effect that we see of applying a positive value of VSB over here. And the second observation is that the depletion region width. So if you see, the depletion region width over here is far more than the depletion layer width which is present over here. And why is it so? Because once you connect a p-n junction diode in a reverse bias, if you see in the junction, it gets depleted of its majority carriers. For example, in this case, the p-type substrate, this area was supposed to be covered up with holes, with a lot of holes, but now because of the negative terminal being applied over here, negative potential being applied over here, all the holes from this particular area will get, or basically we can put it the other way around. Due to the positive terminal which is present over here, it will repel all the holes which are present over here and create a depletion region over here. So this area is depleted of its majority carriers even more as compared to this area because of the positive potential that is being applied at the source terminal. There are other things that will also happen, but this is the first two things that we observe and that we see. So the first thing that the first thing was there was an additional reverse bias that is present in this PN junction diode, and the second thing is that because of this additional reverse bias, we see we see the increase in the depletion layer width. Okay, so these are the two primary observations that we see just as we connect a potential between the source and the body, basically VSB as some positive value. So now what we have to do is we have to increase the gate to source voltage. We have to increase the gate to source voltage in both the areas simultaneously and see what happens, and see, basically find out that particular potential at which the surface inversion happens, because that particular potential will be called as threshold voltage. So we have to find out some value for the threshold voltage. So let's do that. Let's try to increase the gate to source voltage over here and over here as well. So we are trying to we have pushed the first layer of the inversion charges in just below the gate, and same thing we did over here. So in this case, if you increase the VSB voltage, if you increase the gate to source voltage, we saw the formation of the inversion layer over here. We saw the formation, we saw the surface inversion phenomena over here. But the same thing will happen over here as well, but in a different fashion. Let's see how. So first there will be increase in the depletion layer width in both the cases. There will be even more increase in the depletion layer width in both the cases, and even more. And finally, finally this area and this area are completely depleted of its majority charge carriers, which is holes. So once that happens, we have the depletion layer width remains constant. It doesn't increases anymore. Okay. So now what you see is, now when you further increase your gate voltage, let me take one slide back. Now you have to observe this area and you have to observe this area. Once you increase the gate potential even more, you see there is one more layer getting formed over here, and the second layer which is getting formed over here is not so fast. But you see a formation of a layer over here, of the inversion layer over here. Okay. So the thing that we need to observe over here is we have this particular terminal of the MOSFET been connected to the positive potential of the battery. So as a battery just behaves just like a magnet. It will try to attract all the opposite charges. So what in this case, the inversion layer or the n-type charges that is getting formed over here, it gets attracted to the source, and hence you see the formation of the negative charges over here. It's at a very lower rate compared to this one. Okay, so we have this positive VSB over here, and these charges which are getting formed under beneath the gate are getting attracted towards the source terminal, and hence the formation of the inversion layer over here, which it is at a slower rate than compared to this area. Okay, so let's see, we'll try to increase even more and see this area. If you see, the right side of the channel has got the channel is getting formed at the right side of the gate, but at the left side at the area which is beneath the gate towards the left side area, all these inversion charges are getting attracted towards the source terminal. So hence, and for a surface inversion to happen, we form a complete straight channel from source to drain, which is not the case over here, but which is the case over here. It will be happening over here. So see again, if you see this area, the formation of the n channel is very continuous. In this case it is not continuous, but in this case if you see this left side area of the channel, it is getting, or the left side negative charges gets attracted towards your source terminal. So this is the difference of the channel formation that happens in the presence of VSB and in the absence of VSB. So in this case, the surface inversion has already happened over here, and if you see this particular area of the p-type substrate has already converted into an n-type, and the potential at which this phenomena happens is referred to as threshold voltage. So this is what we have learned in the last couple of lectures. So let's call that particular threshold voltage as VTO. So VTO will be the gate potential at which you see a surface inversion happens when VSB equal to 0. So we have to yet to reach to a point at which you see similar kind of surface inversion happening over here as well, which is not yet happened over here. So what we'll do is, since I'm already running out of time, we'll try to continue this discussion in the next video, and in the next video we'll also come up with some equations which will say what will be the threshold voltage or what will be the gate voltage in the presence and absence of VSB. We'll try to club everything in a single equation, and also we'll see how this channel gets formed and at what potential you see the surface inversion happen. Surface inversion has already happened over here at a gate voltage, let's say VTO, but it has not yet happened over here. So let's try to find out the potential at which the surface inversion happens for this case in the next video. Thank you.